Hello guys, welcome to my YouTube channel. My name is Refael Tombokan, and today we are diving into an exciting topic in the world of technology, transistors and the three basic logic gates, NOT, AND, and OR. These concepts are fundamental to understanding how computers and digital systems work. Let's get started. Let's start with transistors. A transistor is a tiny but incredibly important component in electronics. It is made from a material called a semiconductor, such as silicon, and is used as a switch or an amplifier. The transistor has three terminals. 1. Emitter. This is where the current flows out. 2. Base. This controls the transistor, acting like a gate. 3. Collector. This is where the current flows in. Think of the transistor as a faucet controlling water flow. The base acts like the faucet handle. A small movement at the handle, a small current at the base, can control a much larger flow of water, or current, between the collector and emitter. Transistors come in two main types, NP, N, and PNP. The difference lies in how the semiconductor materials are arranged, but their function is similar. Let's focus on the NPN type since it's the most commonly used. In an NPN transistor, when a small current flows into the base, it allows a much larger current to pass from the collector to the emitter. This ability to amplify signals makes transistors essential in devices like radios, microphones, and speakers. Transistors also act as switches in digital circuits. When the base current is present, the transistor is on, allowing current to flow. When there's no base current, the transistor is off, blocking the flow. This on and off behavior is the foundation of binary logic, which powers all computers. Next, we have the NOT gate, also known as an inverter. A NOT gate takes a single input and produces an output that is the opposite of the input. For example, if the input is 1, or high, the output will be 0, or low. Similarly, if the input is 0, the output will be 1. NOT gates are represented by a triangle with a small circle at its tip in circuit diagrams. Now let's talk about the AND gate. An AND gate has two or more inputs and produces an output of 1 only if all inputs are 1. For instance, if input A is 1 and input B is 1, the output will be 1. However, if either input A or input B is 0, the output will also be 0. The AND gate is often visualized as a curved shape in circuit diagrams. Lastly, we have the OR gate. An OR gate also has two or more inputs, but it produces an output of 1 if at least one of the inputs is 1. For example, if input A is 1 and input B is 0, the output will be 1. If both inputs are 0, the output will be 0, 0. Only then will the output be 0. OR gates are typically represented as a curved shape with a pointed end in circuit diagrams. That's all for this video. We've explored the basics of transistors and three important logic gates, NOT, AND, and OR. These concepts form the foundation of modern computing and electronics. Thank you for watching, and I hope this video helps you understand these fascinating topics better. See you in the next one.